Hey guys, in this video we're going to be looking at CNCM Online Round 2 Problem 1, written by me, Eli Park. So first let's read the problem. Audie the baller is shooting hoops and makes a shot with probability P. He keeps shooting hoops until he misses. The value of P that maximizes the chance that he makes between 35 and 69 inclusive buckets can be expressed as 1 over the bth root of A for prime A and positive integer B. Find A plus B. So what we want to do for this problem is that we want, if we let f of x be the chance that Audie makes exactly x shots, which means that he makes his first x shots and then misses the next one, then we want to find f of 35 plus f of 36 plus all the way to f of 69. So now we just want to evaluate each function individually. So f of 35, what is f of 35? So the chance that Audie makes his first 35 shots is p to 35. But remember, in order to make exactly 35 buckets, he not only does have to make the first 35 shots, he also has to miss the next one. And that happens with probability 1 minus p. And then we continue to evaluate the next term. The next term, f of 36, is almost the same thing, except it has an extra factor of p to the 36 times 1 minus p. And this continues, and f of 69 becomes p to the 69 times 1 minus p. And we see that when we go from one term to another, they just get multiplied by a factor of p. And we also know that they all have a factor of 1 minus p, so we can factor that out. So we'll take out a 1 minus p here, and then write the rest, p to the 35 plus p to the 36 plus all the way to p to the 69. And then I'll rewrite this here on this next page. 1 minus p times p to the 35 plus p to the 36 all the way to p to the 69. And we know that this inside parentheses right here looks a lot like a geometric series. And we know that since p has to be bounded by 0 and 1, we see that p to the 35 is going to be greater than p to the 69. So we can evaluate the geometric series started at the infinite geometric series started at p35 plus p to the 36 all the way to infinity, and then we can subtract the geometric series that starts from p to the 70 plus p to the 71 all the way to infinity, and then that difference will just leave us with our desired sum right here. So now let's try to evaluate these geometric series. Evaluating gives that our first geometric series, which starts at p to the 35, is p to the 35 over 1 minus p, and we want to subtract the geometric series that starts at p to the 70 over 1 minus p. So this is what this blue stuff is. And we can see that these both have a denominator of 1 minus p, and this will nicely cancel out with this 1 minus p here. So now all we want to do is find the maximum value of, the value of p that finds p to the 35 minus p to the 70 to be a maximum. And there is a couple ways to finish here, but I'm going to simply let x equal to p to the 35, which means that p to the 35 minus p to the 70 becomes x minus x squared. And this becomes a simple quadratic, and we see that this is maximized when x is equal to 1/2. So that means that the value of p that we want to find satisfies p to the 35 is equal to 1/2, which means that p is equal to 1 over the 35th root of 2. And then if we go back to our problem, it says that our answer can be expressed as 1 over the bth root of a for a prime p, a prime to the prime, and a positive integer b. 35 is a positive integer. So we have satisfied the conditions, and we just want to find a plus b. So our answer is 2 plus 35, which is equal to 37.